Modern engineering relies on a specific baseline. The centralized code host is an absolute source of truth. We build global, automated deployment pipelines around the premise that the central hub itself is secure. Recently, GitHub suffered 3 severe failures. Threat actors exfiltrated over 3,800 internal repositories, a 0-day vulnerability granted attackers code execution on internal servers, and the platform began silently deleting merged commits from production branches. These failures surfaced as the platform attempted a massive capacity expansion to process 90 million pull requests and 1.4 billion commits. These 3 events originate from structural fractures occurring at 3 distinct architectural layers of the ecosystem. We are looking at consecutive breakdowns at the client supply chain layer, the transport protocol boundary, and the state logic layer. Treating a code repository platform as an infallible trust boundary is an obsolete security posture. We start at the client layer. The local integrated development environment, or IDE, is now the primary frontline for supply chain attacks. In May 2026, the threat group TeamPCP exfiltrated approximately 3,800 internal GitHub repositories. The attackers gained entry through a single employee device, compromised by the installation of a poisoned Microsoft Visual Studio Code extension. This vulnerability exists because VS Code extensions operate with the full, unregulated privileges of the host user running the software. A malicious extension immediately acquires broad access. It can read SSH keys, cloud tokens, local password vault daemons, and the developer's .aws credentials file. Threat actors are actively weaponizing this exact level of local machine access, as demonstrated by TeamPCP's self-replicating worm, mini Shai-Hulud. To propagate, the worm steals PyPy tokens to publish packages directly and moves laterally across environments using AWS Systems Manager or Kubernetes kube control execution commands. Zero-trust architectures fail if they ignore the client-side perimeter. Repository permissions offer no protection if the developer's immediate tooling is already hostile. Moving one step deeper brings us to the transport protocol boundary, the gateway where local commits are translated into server-side storage actions. Here, security researchers discovered CVE 2026-3854, a 0-day vulnerability that allowed full server compromise using a standard git push command. Normally, git push options are an intended mechanic. They allow clients to transmit arbitrary key-value strings to the remote server, often to skip a continuous integration hook. When a git push hits babbled, string options convert into an xstat HTTP header. Babbled failed to sanitize semicolons, allowing malicious input to forge a command block. The downstream service, get_rpcd, implicitly trusted these forged headers as legitimate internal requests. Attackers used the forged header to override the Rails environment and force the system to redirect to a custom hooks directory. This execution chain achieved arbitrary code execution, running as the Git user, exposing every repository hosted on that physical storage node. Relying on implicit trust between internal microservices allows a trivial sanitization oversight to collapse enterprise isolation boundaries entirely. The final point of friction occurs at the logic layer, the Git state machine governing historical truth. Git relies on a core architectural philosophy, the absolute immutability and cryptographically verified integrity of historical commits. On April 23rd, an incident involving GitHub's merge queue compromised that integrity, silently affecting 2,804 merged pull requests. Engineering teams use a merge queue to compute temporary merge bases ahead of target branches. This maintains deployment velocity without breaking the trunk. Looking at this timeline, a logic regression caused the system to compute commits from an incorrect base state. The failure was catastrophic, triggering no merge conflicts. The system merged the pull requests while quietly dropping prior code changes. This violates standard Git behavior. History cannot appear reverted or be omitted without explicit, forced user action. The downstream damage is severe. Continuous integration pipelines immediately trigger and deploy a falsified state to production, entirely circumventing automated testing safeguards. When the version control system quietly rewrites history, it shatters the single source of truth that entire engineering organizations are built upon. Reviewing this architecture stack collectively, we observe 3 friction points: unrestricted client extensions, naive transport parsing, and buckling logic states. These breakdowns correlate with the extreme scaling pressures of an aggressive 30x capacity expansion. Following the CEO's departure in late 2025, operations were folded directly into Microsoft's core AI division. This prioritization of agentic workflows coincided with a period of significant foundational instability. Security strategies that rely entirely on the platform's perimeter are no longer viable for DevSecOps professionals. Step 1 is enforcing zero trust on the developer workstation. This requires aggressively auditing and restricting IDE extension manifests. Step 2 is decentralizing deployment trust. Migrate single point of failure deployment logic away from centralized GitHub Actions triggers. Step 3 is implementing robust, read-only fallback mirrors to protect critical infrastructure from sudden upstream history corruption. Security professionals face a new dynamic. They must actively defend their organizations against the structural volatility of the host itself. True DevSecOps maturity requires treating the central code hosting platform as a highly volatile, untrusted node in the supply chain.